Hello my dear students, today we are going to talk about insertion sort. Insertion sort is again one of the algorithms which we use in sorting of the data set. Insertion sort is relatively a simple algorithm which can be applied on smaller data set as compared to the bubble sort which we had done in resource creation assignment 1. To start with insertion sort, let's look at its definition first. What does the definition say? It is a simple sorting algorithm which sorts the array by shifting elements one by one. If you notice in the definition written, it says it sorts the array, that is a given set of elements, by shifting the elements one by one. That is, we move the elements in the position towards the right hand side. Okay, whereas if I'm talking about bubble sort, I am not doing any shifting in the elements. I am replacing the elements with respect to its position. So to understand this definition much better, let's take an example for the same. In this example, you might have noticed that one section or one few of the rows have been colored, whereas few of the rows are in black color. And to the right hand side, we could see that we have numbers which are written in round brackets. Now, what are these talking about? If I am talking that 57034261, these are individual data sets, individual data which I have with me. I need to align this data in a sorted order. Now, if I want to put this data into sorted order, how is it going to work? Now, let's take the first element 5. 5 is compared with itself, hence, there is no shift in the position. Hence, the value to the right hand side is written to be 0. Coming to the next phase, 5 is compared with the next element, that is 7. Now, 5 is less than 7. Hence, there is no change in the data set. Hence, to the right hand side, you observe a 0 again. Coming to the next element, that's 0. Now, if I am taking 0, that is, I am picking up 0 from its position, I am comparing 0 with the first element which I have with me. The first element which I had with me was what? 5, right? So, as 0 is less than 5, I shift 5, I shift 7. That is, I initially shift 7, then I shift 5, hence making place for 0. So, how many positions have been shifted here? 2 positions have been shifted here. Hence, to the bracket, I have written what? 2. Coming to the next element, 3. Again, I am comparing 3 with 0. Obviously, 0 is smaller, so no change. Comparing 3 with 5. Obviously, 3 is smaller than 5. Hence, what do? I shift 7, then I shift 5, and what the position which I am getting, that is 3. That is the position number 2 is where I put in 3. So the shift is about how many positions? 2 positions. Again, observing to the next value, I have the value 4 to be put in. Now, if I need to put the value 4, what do? I compare 4 with 0. 0 is less than 4, no change. I compare 4 with 3. 3 less than 4, no change. I compare 4 with 5. 5 less than 4, no, false. So what do? I shift 5, I shift 7, and the vacant position, that is the third position which I get, is wherein I put 4. Now out here, how many positions have been shifted? 2. Hence I get the 2 to the right hand side. Coming to the next, 2. Now 2 again is compared with 0. Is 0 less than 2? Okay, no change. Next, is 2 less than 3? Yes, it is less than 3. So what do? I shift 3, I shift 4, I shift 5, and I shift 7. How many elements do I compare here? Or how many elements have been compared and shifted here? 4. So to the right hand side, what do I have? I have 4. Hence putting in 2. The similar goes for 1 as well as for 6 if you observe later on. So these are the ways in which I am performing the shift in insertion sort. If you recall bubble sort, you will find that we don't perform any kind of such shifts in bubble sort. We instead replace the element's position. So let's have a brief overview of an insertion sort. Yes, The very first point says that it's the simplest implementation. Obviously, insertion sort is one of the simplest implementation which you could see here. It is efficient for smaller data sets, very true, but very inefficient for larger lists. Managing a large unsorted list, a very large unsorted list, and performing an insertion sort will turn very difficult. It is adaptive. It means that it is ready to work with little bit as the set size increases. Yes, it's ready to work, hence increasing its efficiency. And last but not the least, it's better than the bubble sort algorithm. So here we end with insertion sort. I will like that if you students take the same example which we have done here and solve the same example for bubble sort as well as insertion sort, as it's been run here in a video. I want you students to be doing it in your notebook, making it easier for you to understand how the sort works for yourself. Okay, so we stop here with insertion sort and meet again with some other sorts. Thank you.